1985, a group of British scientists in Antarctica made a discovery so alarming they almost didn't publish it. They thought their instruments were broken. They weren't. Roughly 20 kilometers above us, something remarkable existed. Not a wall, not a dome, just a thin scattering of molecules, ozone, so spare that if you compress the entire layer down to sea level, it would be no thicker than two stacked coins. And yet, this fragile film of gas is the reason life exists on land. It absorbs the sun's ultraviolet radiation before it reaches us. Without it, DNA breaks down, cell dies, ecosystem collapses. For billions of years, the ozone layer held. Then, in the span of few decades, we began destroying it without even knowing. This is the story of what happened next and what it means for every global crisis we face today.
The culprit was a class of chemicals called chlorofluorocarbons, otherwise known as CFCs. Invented in the 1920s, CFCs were considered a miracle of modern chemistry. They were non-flammable, non-toxic, and chemically stable. They were everywhere, in your refrigerator, your deodorant, and your air conditioner. The problem? That's stability. CFCs don't break down in lower atmosphere. They drift upward, slowly, over the years, until they reach the stratosphere. There, intense UV radiation shatters them, releasing chlorine atoms. One single chlorine atom can destroy over 100,000 ozone molecules before it is neutralized. By the mid-1980s, satellite data revealed the damage, a growing void above Antarctica. An ozone hole the size of a continent appearing every spring, deepening every year. The Earth's sunscreen was dissolving.
We tend to think of environmental damage in abstract terms, statistics, percentages. Let's make it concrete. A 10% reduction in ozone coverage was projected to increase skin cancer rate by up to 26%. But the deeper threat was invisible to most people. Phytoplankton, a microscopic organism floating in the ocean, are the foundation of the marine food chain. They produce half the oxygen on Earth and they are extraordinarily sensitive to UV radiations. Scientists estimated that severe ozone depletion could have collapsed marine ecosystem, cascading into global food shortages within decades. This wasn't a future possibility. The oil was growing, the clock was running, and the chemical causing it was still being manufactured by the billions of tons.
In 1987, 46 nations gathered in Montreal, Canada. What they signed that September wasn't just a treaty, it was something rarer, a collective decision by competing nations to sacrifice economic interest for planetary survival. The Montreal Protocol mandated the phase-out of CFCs and dozens of related chemicals. It created enforcement mechanism. It established a multilateral fund allowing wealthier nations to support developing ones in making the transition. Crucially, it had teeth. Nations that didn't comply faced trade restrictions. India signed in 1992. China followed. Eventually, 197 nations ratified it, making it the first treaty in history to achieve universal ratification. Industries that once lobbied against it adopted. DuPont, one of the world's largest CFC manufacturers, pivoted to developing alternatives.
One of the strongest arguments against environmental regulation is the fear that it slows human progress. But this graph shows the opposite. As the ODS shown in blue, a collapse after Montreal Protocol, global crop production continued rising dramatically. In fact, agricultural output accelerated during the same period. This matters because increased UV radiation was expected to damage crops and disrupt food systems. Instead, by reducing ODS emissions early, the world protected long-term agricultural stability while still increasing food production for a growing population. The takeaway is clear: environmental protection did not stop development, it helped secure it. Even though global ODS levels have fallen massively, this graph reminds us the story is not completely over. China still dominates remaining ODS consumption, far ahead of every other country. That reflects the scale of industrial and refrigeration sector. This graph shows the transition from a world dependent on ozone depleting chemicals to one where only a few sectors and regions still contribute significantly. In other words, the problem went from global and uncontrolled to concentrated and manageable. This graph shows the greenhouse gas emissions from the year 1850 to 2024. At first glance, this graph may seem discouraging. Even after the Montreal Protocol in 1987, global greenhouse gas emissions continued rising. But there is a context. The protocol was designed to protect the ozone layer, not directly stop climate change. Yet many ODS were also extremely powerful greenhouse gases. So while total emissions kept increasing because of fossil fuels and industrial expansion, the Montreal Protocol prevented an even steeper rise. This graph helps separate two realities. The protocol did not solve climate change, but it quietly became one of the most effective climate actions in history. This graph shows the growth of greenhouse gas emissions. Before the Montreal Protocol, greenhouse gas emissions were growing at an average annual rate of about 1.75%. After the treaty, the growth rate dropped closer to 1.1%. Now, that may not sound dramatic at first, but across decades and across the entire atmosphere, even a small percentage reduction represents billions of tons of avoided emissions. This suggests that the protocol didn't just repair the ozone layer, it also slowed part of the climate acceleration happening underneath. This graph shows the global GDP levels. The opponents of Montreal Protocol originally feared that restricting industrial chemicals would slow down global economic growth. But after 1987, the world economy did not collapse, it expanded enormously. Global GDP nearly tripled in decades following the protocol. Yes, some growth rates did fluctuate because of recession and financial crisis, but the long-term trajectory remained strongly upward. Industries adapted, innovation accelerated, and economic growth continued alongside environmental recovery. Let us now take a look at major economies before and after the Montreal Protocol. Looking at this graph makes the pattern even clearer. The United States, China, India, Germany, Japan, and Brazil all experienced major economic expansion after the Montreal Protocol era began. China's growth is especially dramatic, transforming from a relatively small economy in the 1980s into one of the world's largest by 2020s. At the same time, ozone-depleting substances consumption was falling globally. This is crucial because it proves industrial development was still possible without continued dependence on CFCs and related chemicals.
The Montreal Protocol's impact extends far beyond the ozone layer. Many ozone-depleting substances are also potent greenhouse gases, hundreds to thousands of times more warming than CO2. By eliminating them, the protocol is estimated to have avoided the equivalence of 135 billion tons of CO2 emissions. For context, that's roughly 3 years of all global carbon emissions combined. Some scientists argue that it is simple most effective climate action ever taken, even though it wasn't designed as climate treaty at all. It worked because of something simple and something rare. Nations trusted the science, they acted before the crisis became irreversible, and they built a system that overlasted the politics that created